Hello, and thank you for joining us for the sixth data analysis bootcamp class. This is a week that we're going to go over all of the data analysis tools that are available in Seaborn and really show you how to use them and when to use them. I think this is a really great class to save, not maybe as a cheat sheet, but save in a really organized place in your data folders on your computer or on the cloud, so that you can have easy access and really come here to reference for different ideas, many different ideas to do for your data analysis. And really the goal is not that you're going to come back to this to copy and paste. You're going to come back to this and use your fingers to help you remember. You're going to use your fingers really to build up these concepts, and so that you're comfortable doing these on your own. And the hope is that these reference materials would be faster than something like ChatGPT or Hugging GPT. Okay. So before we get started today, let's recap the mnemonics from the last class. Okay, so we discussed in the last class being at a wedding and us analyzing kind of not our own wedding, but us looking around and at all the people there, and us being able to tell now with our data analysis skills, analyzing the people, the data points, and being able to really see the relationships between these people. Are they in relationships? Are they not? And maybe determining a little bit who seems like a good partner for us to dance with, and then hopefully predicting who's not only a good partner but who would actually say yes when we ask them to dance. Okay. We also discussed and talked about variable selection, and kind of like my niece at the wedding who loves snacks and treats. She You want to get there before she does. You really want to spend some time in selecting, getting an idea of which of the key flavors, different cupcakes, different desserts that you would want, and get there before your niece does, right? So we really want to do that to help us save some time. We want to make sure that, we really focus on what's important to our analysis, and we're going to spend more time evaluating those because there's only so much time that we have in our days to go through these data analyses. Okay, especially when we have many features. We then discussed we wanted to focus or think about the strengthen the relationship, the direction of our bivariate analysis. Okay, so what is the core relationship of these two variables? Is it positive or negative? And how strong is that relationship? Is it very spread out, or is it really track something like a line? Is it very linearly related? Okay. We want to use this information to help us determine which are the key drivers. We're going to have a business problem, and we really want to understand one thing more than other things. So we really want to factor in what are the key drivers in that analysis. What's really going to bring home the most value for our business partners? What do they really need to understand about this data analysis? Okay. And now we've done a lot of bivariate analysis at this point. I want to eventually get to a point where we're starting to think of we understand our bivariate relationships, and so we can start to assume and think about the tertiary relationship. And we'll see some plots in later sections where we can really start to understand this. Okay, and so this is really important to understand. If this continuous variable is high, what does that mean for these other two? Do they act differently once it's high versus low? Or maybe another category, maybe bivariate relationships work different in a category, or one of the categories of your data set versus another. Really understanding that on a bivariate, multivariate relationship is kind of a natural next step to your analysis. Okay? And really understanding what's important as you build up to that will really guide you to where you would want to go and try to understand that analysis. Okay. We talked about how we get to correlation, which is usually the summary statistic that we use to start our analysis. But to get to understanding why we use correlation, we talked about variation, which really discusses how things move away from the mean and how things move on the other side, left and right, from the mean. Okay, and so we discussed variance so that we could understand how we get to covariance. And really that's, again, kind of thinking of how things move away from the mean, but how things are moving together. Or is one variable generally above the mean while the other one is as well? And, vice versa, they both negative together. And this would be a great metric for what we would like to understand. The problem is to get this covariance, we combined units of measurement. And that makes it a little bit confusing to understand things like you said I had 50 mouse chameleons versus 20 banana oranges. It's kind of like, okay, well, that it's pretty hard to do that comparison, right? So even if we understood really what 50 chameleons are, we have a hard time making comparisons with other metrics. So what we do is we take our covariance and we divide it by the standard deviation of the x and the y, and we get to correlation. So there's a simple metric between -1 and +1, and how tightly packed our variables are around that linear relationship. So are they generally positive or negative? And do they closely pack together? Are they a very tightly correlated relationship where one moves up and the other one moves up the same distance? Okay. We talked about really any summary statistic we have to be careful of because they can be a little bit confusing. Okay. And so here in this one, we want to just, correlation is no exception. It can hide a lot of things. It's a simple summary statistic, maybe not super simple anymore, but it's still a summary statistic and it can hide certain things. So we want to really supplement our correlation analysis with a simple visual inspection to understand, really, is there anything we're missing in this correlation metric? Okay. Things like outliers can have a large impact and distort our correlations, just like our Leaning Tower of Pisa here. You can see our outlier guy is really pulling it in, so it's now upright. We want to understand the true value of the relationship. Having this skew our relationship, having an outlier skew a relationship, so it looks like a stronger correlation than it actually is just as bad as it going the other way. We really want to understand the true nature of the relationship so that we're able to make and provide to our business partners solid information for them to make their decisions. Okay. It's great to recap those. I'll see you in the first section of our 6th data analysis bootcamp class. Okay, we'll show you how to do all these things and how we work with this stuff in Seaborn. Okay, so getting into our data analysis, course 6, bivariate analysis with Seaborn. Okay, so exploring relationships with Seaborn. It's just such a powerful tool. I love Seaborn, and there's some really cool plots that we'll go over today. Okay. So starting with the scatter plot, our kind of classical data analysis tool, really before we had anything else, we had the scatter plot. In the modern day, in this day, I feel like we just have too much data for this to be as practical as it was. You can see here, I tried to turn down the transparency to really give some texture to how much data there is in any given spot. And you can see, maybe generally here, there's a little bit less than there's here. It's hard to really tell exactly. And so there's often too much data. You can play around with this though, especially if you have a smaller data set or a smaller spreadsheet that you want to plot. I think it still can be a good option. And there are some cool things like we can change the shape of the dots that we're seeing. So the question always comes, like our picture here, is if you were to look at any section of the sky, it's how many stars are in that section. It's probably a lot, and it's more than you could count. And for that reason, if you want to know how many stars in any given spot, just looking at the sky is not your answer. And the same thing as scatter plot, really to see, you can see generally that there is or is not a trend, but where is that trend being supported by the data can be really important to understanding that trend as well. And so again, the scatter plot is, you play around with it. It's good in some situations, but I think there are better options that we'll go through today. Okay. A good option that we can have when we have too much data is using the regplot, and has the feature of plotting the regression line as well, so we can tell very quickly where that trend is and kind of highlight exactly what it's doing. And this is really a plot that we want to use to really get to the bottom of a relationship. Really, this guy's he's really looking at these lines in this little map that he's working on, and he's really trying to understand the lines in his data. And that's really what this is really understand that bivariate relationship. What's the direction? What is the correlation? You can see though, there is still a lot of data here. There's a lot of, it's kind of hard to see. Sometimes I have turned down the alpha, so you're able to see a little bit of texture with how much data, but it's still kind of hard to see what's really supporting this trend. Okay, but we can see it now. We can highlight and visualize it, and it can be a really valuable tool if we're getting especially an initial look at how the outliers are affecting our bivariate relationship. Okay. and getting into the KDE plot. Now, this is a really good option for understanding your bivariate relationships, especially when you have a lot of data. Even if you don't, but what it does is it shows where the density really is in our data and kind of works out from the middle. So it shows us where the most dense place is, and it kind of expands out. Every one of these rings would be a little bit less density. There'd be a little bit less values, points, data points inside of each one of those rings as we go away from the middle. Okay. Now this is going to be really, really insightful for just understanding where the trend is being supported in your data. Really, where most of the data is, you'd often surprise, especially from a scatter plot coming to this, how much data is really any given point. And when we look at this, though, a really cool thing is using this to inspect the categories because it's so simple. It's actually quite easy. It's a good option to, just like the univariate KDE plot, understanding how this can then affect our, is affected by categories is really easy because of the simplicity. So we can really see the density of the high category is over here and the density of the low category is down over here. So in very different places, although they both have a lot of the same data, the true density of both of those are in very different places, which is not something you would be able to see very easily in a scatter plot. And if you have enough data, you're getting points covering points of different colors, and you really lose a lot of information that way. Okay, so although it's not necessarily my favorite plot, I don't think it's the most beautiful plot. It is actually just truly very practical for understanding the bivariate relationship when we have too much data, or understanding how a category impacts our bivariate relationship. Okay, getting into a really another useful plot when it comes to bivariate analysis. Really, I almost think of it as the modern day scatter plot, really the go-to plot for your bivariate analysis when you know which two you really want to examine in depth. Okay, so it has the marginal x on one side and then the marginal y on the other side that allows you to plot the univariate analysis along with the bivariate analysis in the center in the joint square right here. Okay. And it's really cool. You have lots of little features. You can use a regular scatter plot here. You can also use a hex plot, which is really beautiful. And very similar to the kernel density estimation plot, the KDE plot, it gives us an idea of where the true density is in our pattern, the darker colors representing where there is more data in that hex bin, in that quadrant right there. Okay. And where there's less data and stuff like this. But you can also tell with the univariate analysis, you get a sense just from this alone, really, here's the most dense place in this univariate, and then right here would be this one. So somewhere those cross section, you could do this great with a scatter plot, then it's supplement it with these marginal univariate analysis. Okay, you're quite cool. And there's a lot that we can do with this, but there's really, to me, highlights the convergence of two features, really allows you to really get right into that bivariate analysis. Okay, so getting into the heat map plot. This is a really valuable plot in our bivariate analysis because the correlation matrix fits really nicely into this. So although the heat map isn't essentially isn't a correlation matrix by default, we most commonly put that correlation matrix into the heat map to highlight kind of where there's more activity in our data set, which relationships do we want to focus on versus not focus on. Highlighting the high traffic areas versus the low traffic areas in a city, you can really see where there's activity going on, which relationships are worth exploring more. A really important thing when you're using this is to note this, make sure that you're actually seeing the correlation that's displayed here. If not, it gets really busy really quickly, or sorry, it's just really hard. You can see which one's generally a more of higher value relationship or a lower value, stronger or weaker, but you can't get a sense exactly which one is more. You could see like 36, but it's 36 more than 37, and being able to see that subtle difference can really narrow down which makes sense to explore, right? So you really want that extra detail when you're using this plot. Okay. Okay, now discussing a plot that is very much related to the correlation matrix. I often run these two in a fairly similar plot in my data analysis, or close together in my data analysis. And just so the thing to realize about a pair plot is it's so busy. There's really too much. It's never usually your final presentation, the plot that you're going to share in your presentation or with your colleagues. It's to help you to figure out what to analyze next. There's so much going on. We get so many sides, so many different views of our data set, and really we can then determine using our human eyes, which are really good at detecting patterns and really see what makes sense to explore, more in depth and to go a little bit further. Where, because bivariate, when you think about that, you're getting that's a lot of relationships that you have in your data set, right? It's exponential. And so it makes a lot more sense to kind of narrow those down and then focus on a few of these relationships that, show a good relationship, show kind of a funky pattern, kind of like this one right here. This looks like it could be almost a sort of correlation, or what's going on here? Why is there a little bit data floating off to this side here? Or this looks like a tighter correlation. Not so much though, but it'd be interesting to understand what density is supporting this correlation right here. Okay, so it kind of goes hand in hand with the correlation matrix that we saw in the Seaborn heat map. Okay, and so this is kind of cool. We can control the diagonal as just the univariate analysis. So when this column 1 by column 1, it would just be the univariate analysis like this, and the rest would automatically plot the bivariate relationships of each feature. So column 1 with column 2, column 1 with column 3, and so on and so on and so on. Okay, and so it really allows you to see so much so quickly, and then from there go a little bit more in depth on the ones that seem interesting. Another really interesting version of this is the PairGrid that gives us access to a little bit more flexibility in how we build this. And I think one of my favorite ways to use this is doing a regression plot on one side. So same thing that we just saw the scatter plot, doing now a regression line on each axis, kind of giving a sense. We're also doing a swarm plot down a diagonal, which just gives a lot of detail on where the data actually is. And then looking at this, we can see downward and positive trends. But it's really interesting to see the mirror image of the opposite side of this regression analysis and really focusing on where the errors are happening. Understanding if there's multicollinearity, heteroscedasticity can be really interesting to understand these errors. They should be random, but if we start to notice patterns between the regression errors and the regression, it kind of lets you say maybe there's ways that we can improve this model. Okay, maybe there's something more interesting going on with this relationship where you see we're missing a lot of the really large values. We almost kind of fan out a little bit, and then we also a lot more orange here on the upper end of this regression. So it'd be interesting to understand why that's happening. Right? Why are we making more errors apparently on the upper end of this regression? And so it's just really helpful to see kind of the mirror image, not the exact same side, but a mirror image, the other side of this regression. Okay. Now the rel plot is a really powerful plot in Seaborn. It's one of the figure level plots, so we're able to separate things by the categories and really focus on even subcategories and really see how the relationships are changing. This type of figure level plot pays special attention to focusing on the relationships. So there's a handful of things that we can do in the rel plot versus the linear model or the disk plot that we saw in the earlier classes. That is also a figure level that can do many things, but the rel plot's kind of special attention is to the understanding of relationships, okay? Which can be, the bivariate, but also how categories play into that relationship. Okay? Another really good plot for figure level plot in Seaborn is the LMPlot. Now whereas the rel plot pays special attention to understanding relationships, linear model pays more attention to understanding the linear relationship, the linear correlation between our data. So it's a little bit different and enables us to do slightly different things. You will find that you can do so many of the same things in each one of the figure level plots. They're really versatile. Plus, one of the main things here is again with the figure level, you're able to use a row to separate what you're plotting on each row, use the column argument to separate what you're plotting on the column, and really then again do each bivariate relationship by the subcategory in each quadrant, and then even change the hue color to do subcategories and really start to understand how that very subtle bivariate relationship, that linear relationship, changes as we get deeper into the data and we start subsectioning data in really kind of doing that very granular look. And that's when you'd want to use one of these is either the rel plot or the linear model plot. You'd want to use you're very deep into, you really want to understand that you want that level of detail. These are not plots that you would maybe start with, but these are plots that you can use to investigate a little bit further and see if there's something that you're missing when you get down into that level of detail. Especially you would want to make sure that you have enough data to support these relationships at that point. Okay, so some of the last things that we'll talk about today is, well, some of the plotting features, functions available in Seaborn, the data brewer, the color brewer, that generates different color palettes that can be really, really handy, especially in just specifically in aiding our data analysis. One, it's nice to have good looking plots, but it also lets us, with the diverging palette, highlight in different colors the positive and negative end of the spectrum, right? So this is really valuable when you do when you have positive and negative correlations in your data set. So it's one of those things that knowing how to get, fine tune the colors, is one to understand, how to make art and beautiful plotting, but and communicate your results in a nice clean way. But it's also very important to understand how to use those colors, with our eyes to better understand where the positive and negative relationships are. And this is really when you'd want to use the diverging palette. The other color generator that I often use is light palette, and this goes from the color that you choose from white up until it's better to use a dark color, and you start with light and you go to the color that you've chosen. This is really good at highlighting when there's one magnitude of value. So either positives or negatives. You're not really looking to analyze the kind of up and down relationship. You're looking to evaluate kind of one direction more so of this relationship. Okay, so it's really good for highlighting the positives or the negative values. And either one of these, they're very customizable in the colors that you'd want to use. And it gives you lots of flexibility to make your reports a little bit made for your business or made for the situation, the business use case business situation. Okay, so some beautiful plots in Seaborn. Okay, and so recapping our mnemonics from this class, we start off by talking about the scatter plot, which there's just so much data these days that it's truthfully, it works well in the sense that you can generally see a trend or not, but it's hard to really tell how much data is supporting any given point of a trend or pattern. And that can be really helpful in really understanding how worthy something is of investigating. So I wouldn't say I use the scatter plot a lot, but it's kind of the classic plots. That's where we started. There's a few little options that we can change in it, but there are much better options in Seaborn for if you have more than 1,000 rows, that can make a better option. Okay. Next one that we discussed was the reg plot, which is one of the better options than just the scatter plot by itself. It adds the regression line to the scatter plot, and it generally allows you to see the general direction. It also gives you a confidence interval to see how confident we would be in that position of the regression line. And from there we went to the KDE, the kernel density plot. And the KDE plot is great. It kind of looks like the rings of the trees of a tree, but here it really shows specifically where the density of our plot or our bivariate relationship is. And because of its simplicity, it works really well as a way to inspect the bivariate relationships by a category, changing the hue by a category you have in your data set. And it can be really, really helpful because of its simplicity. We can add a little bit more details without it becoming too overly cluttery as we go through it. Okay. We then talked about the joint plot, which really allows us to examine the convergence of two variables. And it's really, I would say, the modern day scatter plot, your kind of go-to option instead of the scatter plot. It plots the the univariate relationship on each axis, which allows us to, even using the scatter plot in the center, allows us to really understand where the density of our data is. We can also use the hex bin on this one, which is a really beautiful plot, as well as even putting the KDE plot in this. Okay, so we have the flexibility, and we can change both the univariate and the joint square plot independently as well, which would be fun, and we'll see that in our notebook today. Okay, we also discussed the heatmap plot, which shows the kind of where the activity of our variables are. We put the correlation matrix in that to really highlight where the positives and negatives correlations are very easily in the in this plot, and so it works really well in that sense. Okay. We also discussed the pair plot, which allows us to very quickly visualize and see all of the bivariate relationships in our data and understand which ones would be worthy to inspect a little bit more, because the truth is there's just so many. Deciding which ones are worth investigating a little bit more can take a little bit of time. Okay. We discussed from the pair plot, we discussed the pair grid, which allows us even more customization on the pair plot. But a really cool thing that I like to do is doing the regression on one corner, and then on the upper corner doing maybe the residual plot. So kind of two sides of the regression line you can see very quickly and easily, and it highlights really where you might actually have some patterns that you weren't able to see in with another way. Really seeing that regression line contrasted with the other side of the regression line, that where the errors are, can be very helpful in understanding, what's worthy to inspect a little bit more. What bivariate relationship am I curious about? Would I like to do more? We discussed the LMPlot, so understanding it's made to understand the relationships in our data, and then we discussed the LMPlot, which is made to understand the linear. This is the linear model plot. It's made to understand the lines, the linear relationships in our data, and they're both figure level plots, the rel plot and the LMPlot, and so we can separate, do a few plots dividing the rows by the categories and columns by the categories, and then even change the hue color, so you can get really deep into how sub categories are affected by their categories. Okay, and really how this affects the linear relationship on one side and how it affects the just relationships on the other side. Okay, so this really allows you can do a lot of the same things in both of them, but the rel plot focuses on understanding relationships, and the linear model focuses on understanding the linear relationships. Okay. We also discussed the diverging plot and the light palette. And so what this is the diverging palette will allow us to highlight positive and negative relationships. It's nice to kind of tailor the colors for your work situation, but just even using the colors to make it easier for us to see the difference in the positive and negative relationships can be really valuable. Okay. The light plot is more used when you have just one magnitude of values, and it would just be good to highlight the ascending values of those versus positive and negative. Okay. Okay, so we talked about many mnemonics today, so, logical, different colors that we connected to, and so we had word associations. We finished this off today. I talked a lot about in 3D spaces, just to kind of, when I was discussing a plot, to kind of really allow our brains to more easily remember those 3D spaces. Okay. So one of the ways that we'll recall this is review this in the next class, but a really good thing for you would be to review the presentation that I went through and just make sure, there was a lot of detail that I didn't discuss, all the notes that I had. And so it'd be good for you to go back through and read the notes of when to use and when not to use each and every plot. Okay. So thank you for joining me on the presentation, and I'll see you in the Python notebook. Okay, so going through our bivariate class with Seaborn, and we'll get started. Okay, so going through the red wine data set today, and a common thing, although we're going to do bivariate, still is nice to understand my data in any sense and help me understand what I should be expecting to see. So plotting the univariate relationships just quickly in a loop, 4 feet in df.columns, the figure, the histogram, and then making sure I show the plots. Okay, this really just highlights and lets me know kind of what I'm seeing a lot in my relationship. Seeing lots of outliers I would expect to see, and pay attention to those then, how that might be affecting my bivariate relationship. Okay. Because I don't like the standard, well, I mean, the standard colors are fine. I gotten bored of those, so I like to change the colors a little bit. So I have another palette here, and then which is this, turns out to be this. And so we're gonna go set palette, put the list of the different colors in here, And then what I'm doing in this next line is just so that I could see what colors in my palette are. Maybe I want to change them around a little bit, get them sitting a little bit better. I'm just going to then go sns.color palette and just kind of show those colors right there. And it'll give me a list of the red, green, blue of each one of these colors. So going on from that, then looking at our, starting off with our scatter plot here, do plt.figure, sns.scatterplot, data equals df, x equals volatility, and y equals another continuous variable right here. Okay, so two continuous variables. One of the things that we can do in with a scatter plot, there's not a whole bunch we can do truthfully, and so changing the marker is one of them to square or to triangles. You can also change the size of your values, and you can also change the alpha. Okay. So then reg plots. So not really truly a whole bunch you can do, but you can see even turning down the alpha, it did help. Is it the ideal plot for understanding how much data really is in any given spot? You know, I don't know. I wouldn't really say it becomes a little bit more difficult at this point with this much data. Okay, reg plot. So same thing, x and y in our variables. We're just calling the s and s reg plot this time. And then we can also do things, I think this is a really great practice, doing something a little bit more advanced with Seaborn, and then with your plotting functions and being able to, you know, get good practice with Python. This is changing a sub-level function. So regplot is made up of two other plots. So it's made up of a line plot and a scatter plot. Okay. And so anything that we pass that scatter plot up above, we can then change those options right here. So I'm going to change the color of this, the plot, the scatter, the dots, to one color for my palette, and then changing the color of the line to another color for my palette. Okay. Getting into the KDE plot. So this is, it's a very simple plot. I don't know if it's my favorite, but it works really well in certain situations. Okay, so doing the X and the Y here, we're doing bivariate, and it goes into the KDE plot. And then we're gonna go change the quality, the hue, by a continuous variable, right? And so you can see, you can start to see, even with this many, you can really start to see, okay, the higher colors are over here, the lower colors are down over here. It's a little bit busy, but you get the sense of that. And I think a better way would be to use a category that's a little bit more simple than a continuous variable like this. So we're doing here quality. I'm going to break it down in just low and high and remove kind of the continuous aspect of this variable, just now making it two categories, high and low. And you see when you plot those two, using those as the hue, you guys are able to really understand where those densities are, right? So this is simple. We want to make sure not to clutter it as well, but it would be hard to see something like this in a scatter plot because the dots would just be so much on top of each other, and you wouldn't really understand that over here is really where the density of one bivariate, you know, the bivariate by the category is, okay? And so the category here for this bivariate relationship is way over here, and so you're getting a sense that this relationship, alcohol and volatile acidity, has something really important to do with our target, and maybe it gives us a sense of what we could engineer for machine learning, what we'd want to pay attention to in this plot as well. Okay, joint plot here, going into same way that we use it. We're using the joint plot now, but we're going to use x and y here, and you can see that it's doing the two variables right here, and doing the univariate axis on one and univariate axis of the other, and then plotting that. So you can, even before we do anything else with this plot, you can start to get a sense of, well, here's the highest histogram here, here's the highest histogram here. Okay, so I think my highest weight of my data is actually right here. You wouldn't be able to see this in another way, but it's somewhere right here. Okay, so let's just get a better understanding of this. Okay, we can use the hex plot, which is a beautiful plot, and give us the same thing as a two-dimensional histogram would give us, in the sense that the colors are coding how much density is in any given spot. Okay, so the darker the color, the more data we're actually seeing at this point. Okay, and then we're going down here. We can also do the KDE plot right in this as well, using kind equals KDE and kind equals hex here to do the hex plot. And then we can add, when we do the KDE, we can change the hue argument. You can't do this one with the hex. So with the hex, you can't use the hue argument, which is too bad. I think it would look really cool, but it doesn't work. And so here you can see really getting a sense of, again, the univariate on either side, and really you can see it's much more affected by this. Alcohol has a lot more interaction with the low category versus the other one here. So making some comparisons about between the bivariate relationship, which is maybe impacting our category more, which is the one that we want to pay attention to more. Okay. And having some fun with this as well. Doing a similar thing that we do, we passed arguments to a sub function. So in the joint, we're doing a hex plot. In the marginal, we're doing a histogram. Okay, so here I'm going to say in the joint, do bins for, in marginal bins, KD equals true and line width equals 3. Okay, so you're doing the histogram here, adding a KD plot to this, and then changing the hex bin to only say I only want to have 4 bins. For hex plot, the bins are the shades of color, right? So white, light, medium, and dark are for levels of plots, right? And so it kind of just gives you very generalized where the data is, and really, oh, here's the most important part. We can go the other way, and you could do something like 40 colors and really showing all of the detail in our hex bin, right? Going from the lowest to the highest, and really visualizing this in quite well. I'm also in the histogram, I'm going to go fill equals false and line width LW equals 3 to make them a little bit thicker, but make sure there's nothing on the inside as well. So many things that you can do to get the desired effect and really to assist in your data analysis. Okay. Going into the heat plot. So the heat plot, we most often put a correlation matrix, which has the fixed acidity by fixed acidity correlation is 1, and then all the way down the diagonal then is where we have the relationship with itself, which is always 1, right? Correlation with yourself, and then we can measure the fixed acidity with volatile acidity, negative 0.25, citric acid 0.67, residual sugar 0.11. So really, getting a sense of all these, you could go through all of this like this if you want to. It's a little bit busy, so we can put it into a correlation matrix, and so you just go sns.df.heatmap df.core and sign that. I think a way that I prefer to use it is turning up the line width. You get a little bit of spacing in between, and then I think as well putting it on a figure here, making it a little bit bigger for us to plot can be really helpful. I also think it's really important to note this and making sure that we're displaying the actual correlations here. It can be a little hard to see and understand, okay, yeah, this one's bigger than this one, or wait, which one's bigger, right? These both are darker here. It's kind of hard to see at this point which one is more negative, right? And so, and we can see they're actually 14% different, right? So it's quite a big difference, right? So we want to be able to understand that a little bit better. The colors are great, and they guide our eye to where to see, but we need the numbers to kind of finally decide, what's stronger, what's really worth investigating. Okay. I don't like the standard colors of Seaborn. I just say they're not my favorite. So then I do the crest blot normally, and it makes it nice. I like this color palette too. If I wanted to do something a little bit different, I could do the light palette here, and it would show just putting a color that I've gotten from colormind.io. Lots of good colors there. It's an AI color generator, and so it seems to know what I like. And so just here, this is great. The light palette is great for when you have one direction of colors. And because we have positive and negatives, we can actually do the diverging palette. We're giving two different integers from 0 to 360. And the center is light here, so we can see we get nice different colors and really highlight which is negative and which is positive in our data set very quickly and easily. Okay? And get a really sense, okay, now we can really focus, okay, let's really start to understand these really higher correlations right here and kind of ignore all the stuff, that's not really super important. Okay. to kind of assist in understanding these correlations, we can use sns.pairplot and very quickly visualize many of our bivariate relationships in our data sets. And so the one thing about this is you don't want to be looking at and analyzing everything in detail. You want to kind of step back and look and see where my eye is drawn to, right? Okay, so I see a little bit of a correlation here, here. Curious to understand why fixed acidity has these two correlations, are very highly correlated or more so correlated with these two ones. Maybe understanding what's going on, why there seem to be outliers on this side right here caused by chlorides. And this gives you a higher, level to go and understand which ones do I really want to explore. Maybe this one right here would be good as well, and understanding those relationships. But now I don't have to go visualize all of these. I can just, happy with what I did, and I can go a little bit deeper. We can also put a his plot into this and look at a two-dimensional his plot, which is very similar to the KDE plot. And the darker the color represents, the higher the density of supporting this trend. So, this trend, these two trends, they look like a good relationship across the board. You can actually see there's only a little bit of data, or most of the data isn't really the center of this. There's not this whole, that looks like a line here that supports this. It's not really, there's really not a lot of data outside of this little center range right here. Okay. It'd be kind of, is this maybe worth exploring then? It's one of those things that we need to think about. If we have enough time, maybe yes. If we don't, maybe no. Okay. Here we have a corner equals true, just to turn off the duplicated side if you didn't want to see that. You can also do diag kind, and we're going to put diag kind equals KDE, and look at the KDE on the diagonal, just kind of showing lots of different options. As we work well, if we're going to do the hue equals category, and plotting then a reg, kind equals reg, and KDE on diagonal. So those are good, and there's a lot of options with the PairPlot. I really like the PairGrid if I'm going to do this. For lots of different options, we have lots of flexibility in this. Okay, so we're going to do SNS PairGrid, g.diag, map diag, KDE, regplot, and hisplot as we go through this and start to understand and explore this relationships. Okay, really gives us a good sense of, here we're looking at a histogram down on the left-hand side. Really, we can see where the density is supporting then this regression line here. So if we see this regression line here, you really see actually really not a lot of data supporting that whole line. It's all right down here at the bottom, right here. There's not really a lot of data up here. And so is that linear relationship really worth investigating if most of the data isn't there to support it? Another thing that we can do is hisplot, KDE, and lineplot, and just showing it, turning down the alpha, just to be able to better visualize the categorical relationships with the data. And then one of my favorite ways to use this is the swarm plot with the resid plot with the reg plot. Okay, so swarm on the diagonal, resid plot on the upper, and regression plot, reg plot on the lower. Okay, and the way that, just to highlight this, the way that I am passing then arguments to resid plot is not going to be resid plot. It doesn't have the parentheses after this. And so what's actually happening is we're referencing this plot, and then map upper is going to take control of this, take responsibility of using this. And so in that, we're going to go scatter plot KWS. We're not going to give this to regplot. We're giving this to the map upper, and it's going to take responsibility of passing these arguments. You can even see the size of the dots here in the swarm plot is we're passing that argument to the map diag and not to the swarm plot. And map diag will take responsibility of taking control of that function and then how to use it, and then it will pass that argument to it. Okay. Same thing here with the scatter plots, turning down the scatter portions of the reg and the residual plots, and then the size of both those variables. We get a really cool effect in this, and you can see here, swarm down the side, you really get a lot of detail when you do this in the swarm. It just really gives you a lot of detail, and you really see, it's interesting how this one variable citric acid by itself, we're looking at that, has a lot of truncated. All the other elements seem to be very uniform in their um, densities across the univariate densities. Kind of interesting to understand that a little bit better. And that could have something to do with when you look at these relationships, the citric acid with the fixed acidity right here is not really, it looks like a good relationship right here. It looks like we did a good regression line, but when you look at the residual, actually I'm seeing a little bit of spreading out here, which is called heteroscedasticity. But it looks like there's a little bit of a pattern, and you're also noticing here that orange is more on the upper side and green is more on the down side. And so we seem to be missing the orange a lot more. Why would that be? Is that related to this univariate, this detail in the univariate relationship here? We're seeing a lot of density, 1 point right here on the higher end of this univariate value. Okay, this is kind of interesting and worth, you can spend a lot of time getting lost in that and just explore a little bit more. Okay, getting into some of the figure level plots. Okay, so making a couple other categories here, just have more categories to play around with the colors. So making one for volatile acidity category, medium, high, low, and making one for alcohol. Just to highlight here what was happening is I'm putting bins or the outside edges. So I'm going to have one more outside edge number of bins, so low, medium, and high as well for the alcohol category as well. Okay, so getting into the rel plot, we're seeing free sulfur dioxide, total sulfur dioxide, kind equals line, and then row equals category. So we're going to do the alcohol category for each one and really just understanding how this linear relationship, this line plot is different between those two. And also do scatter plot here, changing that, turn down the alpha, and really start to see if we can plot that bivariate relationship by the different levels of alcohol, right? Now broken up by that. Change the size here by the quality to highlight, and this would be maybe the target, the likely target in our data analysis in this use case. And so now we're able to change the color by another category as well, which is a little bit interesting. This is the only plot that this is available in, so it's kind of interesting that we're able to do it. We don't have many on this end of this variable, so that's probably why we're not able to see so much, but it is nice that we're able to you have that feature available, and you could probably find a better plot that would work with. Okay, the LMPlot is the linear model plot. So just the same thing. So X and Y, if you wanted to, you can also then change the row and add in a row argument to this. So just focusing on the bivariate relationship here, we can do the C confidence interval. How do we want to understand this confidence interval? And so we're saying 99%, so it would be a little bit wider where we can make sure we're going to be 95% sure that our regression line is going to be somewhere in between these plots. Another cool feature is we can turn up the order. And so to do a second order regression line and really understand that curve, I find second orders really highlight the linear, like how outliers are affecting your distributions. And so I think it's really important to understand and can be a little bit, or certain affecting our linear relationships. So we'll watch those correlations and we turn up the order. Okay. One of the many things we can look at. Here I'm going changing because this is a figure level, the way you change the size of these plots is you're going to go height and aspect. An aspect is just saying how many times the height do I want this to be. So it's a little bit wider here because my height is 4 and then 5% more than that on the aspect. Okay. And you can see with the higher order here, really highlighting where those correlations are kind of out of whack and stuff here. Okay. You can do then row and column here and by two different categories and really start to separate by the subcategory, volatile acidity low, alcohol low here. Very tight linear relationship when that happens. It doesn't hold true for all of these categories. You can see total sulfur dioxide when it's the medium category and the low alcohol, it seems to really not that straight tight line that we saw up here. Kind of pulls down. Again, could be these outliers over here, but really not holding that tight linear relationship anymore. Okay, and another cool feature here, changing the quality, the hue by the quality category. Really plays around. Get some sense of how that sub category is allowing you, affecting those relationships. Okay, so and then just having a little bit of fun with this, I'm going to pass the line KWS and the scatter KWS, just like we saw in the reg plot. I'm going to change the line width of the line, making it a thicker line. I'm going to change the size of the scatter and turn down the alpha. Okay. We cannot do the changing the size by the another category in this one. That was only working in the rel plot. It's just different features, whereas the order is something that we would have available in the linear model plot. Okay, so really, depending on, do we want to focus on relationships or do we want to focus on the linear model or the linear relationship in this sense? And just, I think you got a really cool effect from here, and you're really seeing how those outliers are really pulling this order, the third order regression line, in different directions, and really kind of highlighting it's not maybe as, except in one of the categories, it's not such a great linear relationship anymore. Okay. Moving on from that, making another category here, and then going into the diverging plot. So this allows you to kind of go through and choose a good linear model plot here. So if you do the SNS diverging palette, or sorry, and it's a good colors to choose for your representing your positive and your negative correlations. So this goes from numbers 0 to 360, and there's a way that we can actually choose that. We'll see that here. Light is 65, center light, CMAP true, and 9 is the different colors. So we're going to see 9 different colors here. CMAP equals false. So when CMAP's true, it goes continuous, and when it's false, it's going to do more of a kind of jaggedy line. Okay. And I honestly find I have to kind of play around with it, but most any random number between 0 and 360 together really tends to work quite well. Okay. If we're not sure though, what we can do is we can use this SNS diverging palette algorithm to see how our plots look. And so what we can do is we can play around with this negative. Oh, okay, no, those don't really go too well together. I'm going to put this down and get two different colors and really help me choose which colors make the most sense. S is the saturation, so if I turn that down, you'll see that it gets kind of not a lot of color. It's quite big. And if you turn it up, it goes kind of brighter color. Light is how, or L is how light you want your plot to be. Do you want it to be very light or very dark? Okay. Kind of either side of those. So we're in the middle would make more sense. Okay. And then we also have separation. So sep is how much white color there is in the middle. So if you do turn this up, you're going to see you get more white in the middle. Okay. And then N is the number of colors, and you could change it even to a dark palette as well. Okay, so the center is dark instead of light. Lots of different options there. I played around and I found these two to be the ones that I liked. And I'm just going to put this in the CMap of my heat map and now have a nice custom made color palette for this. Okay. We could also do dark palettes, giving it a red, green, blue set of colors here, and then changing the CMap to a node equals true. CMap palette that I just created up above, and you get the dark palette, and you also get the light palette here. Okay, and really, which one I find the light palette is a lot more valuable in most situations. I think just going from a light color to the color that you've chosen makes a lot more sense. But then going from a dark color to the color you've chosen, whichever you prefer. I think this is really handy as well because you can actually just choose a color combination and put it in here, just the string that represents it as the first color instead of these red, green, blue, the three colors here. So it can be a little bit more handy in customizing your plot for some given situation. Okay. So thank you so much for joining me today, and I will see you for class 7.